Alright, so here we've got a matrix equation where the matrix is a 3 by 3 matrix. So first thing we want to do, we want to verify that that these three are solutions. Okay, so to verify, we plug them in, right? So first of all, I'm going to plug in x1. I want to make sure that x1 prime is the same as this 3 by 3 matrix. Times x1. Okay, now what does x1 look like? X1 is a constant. There are no t's in here. So the derivative of a constant is going to be 0. So it's actually all three components are going to be 0. Okay, and I just have to make sure that that's the same thing that you get when you do the matrix multiplication on the right side. Okay, so actually let's just go ahead and do it right here. So to do the matrix multiplication, remember it's a bunch of dot products. So we do the first row and the first column. So it's going to be 1 plus 12 minus 13. Sure enough, that's 0. Okay. Then it's going to be the second row with that column. So that would give me 6 minus 6 plus 0. That's 0. Okay. Then it's going to be the third row times the column, which would give me negative 1 minus 12 plus 13. That's also 0. Okay, so that proves that x1 works. Okay, x1 is a solution. Okay, what about x2? Okay, well, let's see, x2 is right here. It actually has an e to the 3, it has an e to the 3t here, so the derivative of x2 would be 3 e to the 3t times that vector. And we just need to make sure that that's the same thing that we get when we do the right hand side, when we do the 3 by 3 matrix. Times x2, which, let me write it like this. I'll write the vector first, and I'll leave the e to the 3t out here. Right, so I can do the matrix multiplication first. Okay. So let's see, let's go ahead and do the matrix multiplication. So we would have to do, again, we have to do first row times the column. So that would be 2 plus 6 minus 2. That's 6. Then we'd have to do the second row times the column. That would be 12 minus 3 plus 0. That's 9. Then we have to do the third row times the column. That would be negative 2 minus 6 plus 2, which is minus 6. Okay. So the question is this the same as this? And I think you'll agree that it is, because really if you took this 3 and put it into the vector, you'd have 6, 9, and negative 6, which is exactly what we got here. So yeah, x2 also works. Okay. Let's see, I'll do x3 over here. Okay. So x3, I want to know if x3 prime is the same thing as the big matrix times x3. So let's see, what would x3 prime be? It would be negative 4 e to the negative 4t times this vector. And I want to know, is that the same thing that I get if I do the 3 by 3 matrix times that x3 vector? So again, it's a exercise in matrix multiplication. So if I did, if I do, first row times the column, I'd have -1 plus 2 plus 1. No, at -1 plus 4 plus 1, that's 4. Then I'd have second, if I did the second row, I'd have -6 minus 2 plus 0, that'd be -8. Then if I do third row times the column, I'd have +1 times -4, or plus -4, and a -1, so that'd be a -4. Okay, whoops. So that's what you get when you do the matrix multiplication. There still is that e to the -4t there. And yeah, again, the question is this the same as this? And yeah, it would be, because if you take the -4, put it into the vector here, you'd have +4, -8, -4, which is exactly what you got here. So x3 is also a solution. Okay. Once we have 3 solutions, and they are linearly independent, I'm not going to prove that, you can write down the general solution. The general solution is just going to be a linear combination of those. Okay, so the general solution is going to be x equals c1 x, yeah, no, I guess I'll actually write out what x1 is. So it's going to be c1 times x1 plus c2 x2 plus c3 x3. Okay. Once you've got three solutions that are all the same, then the general solution is going to be a linear combination of those. Okay. Now you want to find a particular solution that satisfies this initial condition. That's just going to be a matter of solving for C1, C2, and C3. So let's see. So if I plug in x equals 0, I'm sorry, if I plug in t equals 0, that's what I'm doing here. That's just going to get rid of the e to the 3t's, or the exponentials. So let's see. The first coordinate would be c1 plus 2c2 minus c3. That would be equal to 0. The second coordinate would be 6c1 plus 3c2 plus 2c3. We want that equal to 0. And then the third coordinate would be -13c1 minus 2c2 plus c3. We want that equal to 1. So you can take that system, RREF it. And if you do that, I get C1 is -1/12. C2 is +2/21. C3 is 3/28. Okay, so you plug those constants into the general solution. That would give you the particular solution to this initial value problem.